Now we're ready to solve nonlinear systems of equations, meaning equations that do not form straight lines and intersect. They're going to have exponents in them or other fun functions such as exponential and logarithmic functions. You can still solve them with substitution or elimination, but it means the algebra to get to the final answer may have a few extra steps. So we're going to compare these two we have here side by side. You have done problems like this before. In Algebra 2, you would have solved conic sections where we had similar type problems, and we found where two conic sections were intersecting. In this case, and also as a good review, if you look at the first problem on the left, the top equation, x plus 7y equals 50, you'll notice there are no exponents in that problem, which makes it what shape when graphed? And hopefully somebody is there saying it's a line. Now the second one we haven't done since probably November. What do you get when you have x squared plus y squared equals 100? That is, of course, our friend the circle. Center is at 0, 0. Radius is 10 units because you would do the square root of 100. That will become important at the end of this lesson. You'll notice here the big question is going to be for you, should I do substitution or elimination? In this problem on the left, could I do elimination? And the answer would be no, because my x's don't have the same power, my y's don't have the same power, so there's nothing I can eliminate. So in the case of the one on the left, I'm forced to substitute. Now, the one on the right, that's a different story. I could eliminate the x's because they have the same power. They're both x squared. The y's could not eliminate, but I could do the x's. So we're going to do both of those, and we're going to do it in that form. While we're talking about it, though, over here on the right-hand one, what is x squared plus y equals 13? Well, what's any function in which x is only the x is squared? You've graphed many, many, many of them in your mathematical lives. And yes, that's our friend the parabola. The second one, once again, x squared plus y squared, as long as you're adding, no coefficients on it, that is indeed another circle. So this one you'd be figure out where the parabola and the circle intersect. One on the left is where a circle and a line intersect. Okay, the one on the left is the one we're going to do first, and we said, okay, I have to use substitution because I do not have the same exponents. Okay, when you go to decide which variable to isolate on substitution, do the variable, actually I think I want that in another color. You want to isolate the variable with the smallest power and coefficient. So in other words, you rarely want to isolate something with a square if you've got something to the first power you can do. So the big thing is then, as far as first powers, do I want to do the x to the first power or the 7y, which is also a first power? Well, which one's going to be easier to isolate? Of course, the x is. So yes, I am coming down here and doing x equals 50 minus 7y. So I've isolated the x. What am I doing with that x? I am substituting it into the other equation. So in place of this x squared here in the bottom equation, I'm replacing that 50 minus 7y. Now it is super crucial that you pay attention to the exponents. That's going to be a quantity squared now. I'm putting 50 minus 7y in there, squared, then I'm going to still have plus y squared equals 100. And the big question of the day, how do I square that binomial? And of course the answer is FOIL it. We should know that one by now. So you're taking 50 minus 7y times 50 minus 7y. And yeah, these are kind of big numbers. Have to live with it. So if I FOIL that, that's going to be 2,500 minus 350y minus another 350y plus 49y squared. Then don't forget the plus the single y squared equals 100. We have to get all the parts. Okay, I'm going to combine like terms, and I'm going to get highest power up front here. So I'm now going to have 50y squareds minus 700y. And when I bring 100 over, I'll have plus 2400. So this is definitely a quadratic with some pretty big numbers in it. Is there anything we can do to make it better? Well, gee, if nothing else, looking at all those zeros, I can definitely pull a 10 out of it. But in reality, I can pull the whole 50 out of it. So if I pull 50 out, that's going to give me y squared minus 14y. If you take 50 out of 2400, you're going to discover it's 98. Now, the question is, can I factor that? Excuse me, it's 48. Can't read my own handwriting. Can I find factors of 48 that will make a 14 in the middle? Sure. I'm going to get, I think at 48, I can use 16 and 3, 4 and 12, 6 and 8. Well, I think I'm jumping on that last one. 6 and 8 should do the trick. Both of them have to be negatives to make a plus in the back. And so I would now have solutions of y equals 6 and y equals 8. Now, the question is, are you done with the problem? And that answer would be, nope, we're not. Because we've only solved for y. Remember, we are finding where these intersect. So I have to find the coordinates. All my answers here will be coordinates. What are the coordinates of where this is intersecting? So I have to find a way to go get x. Well, on substitution, there's always a great way to get x, and that's back up there where you had circled in orange, x equals 50 minus 7y. So we are definitely going to remember that that's the equation we knew. So consequently, I can actually, if I plug in y equals 6, I'll have 50 minus 42, or 8. If I plug in y equals 8, I'll have 50 minus 56, which will give me negative 6. Now be sure you write those answers as coordinates, because they are the point of intersection, and in the correct order. So the top ones would be the coordinates 8, 6, because x has to come first. The other one would be negative 6, positive 8. And those would be your two solutions and your two intersection points. Sometimes these can intersect more than 2 times, so don't be surprised if that happens. That was a pretty standard substitution problem. Key thing there in the middle was foiling it. Okay, our second problem, we'll see if the algebra reduces any. The second one, we decided we could do elimination because we see that we actually have 2 x squareds in there, and so we can make the x squareds eliminate. Consequently, if I'm going to do that, I'm thinking I'll take the top one times a negative 1 and get my x squareds to eliminate. So I have negative x squared, negative y, and a negative 13. The second equation I'm leaving alone. When I add down, x squareds are gone. Now, can I combine those y's? The answer would be no. One of them's y squared, one of them's y. So I'm actually going to write that out as I have y squared minus y equals 12. Well, that's a pretty easy quadratic. I set it equal to 0. Subtract my 12 over. Okay, I need factors of 12. That'll get me a negative 1 in the middle. That would, of course, be negative 4 and positive 3. So y equals 4 and y equals negative 3. Am I done with the problem? Absolutely not. I have to find the points of intersection. I know that in this case, this problem, this circle intersect when there's a y coordinate of 4 and a y coordinate of negative 3, but I need the x coordinates. And this is where it becomes your choice. We don't have a specific equation to sub into. Just go back to one of the originals. I'm going into the top one. So I'm opting to use x squared plus y squared equals 13. And if I put in y equals 4, that will give me x squared plus 16 equals 13 which means x squared equals negative 3. Well, is that an issue? Well, can I have that happen? If I put 4 in for y, and you would look at that and go, okay, can I have x squared equal a negative 3? And the answer there would be, no, it can't. So because if I square root it, what's wrong with that? Yeah, you can't have an imaginary answer. Just making sure. Oh, no? Oh. That would be because I was sitting, sorry, knew this was wrong because this wasn't working right. I didn't copy the problem right. It's x squared plus single y, not y squared. I was going, that doesn't jive. Let's try that again. So x squared plus 4 equals 13 means, well, that's going to be a little better, huh? X squared equals 9, square root it, x equals plus or minus 3. So now I would have how many answers? And hopefully somebody out there is saying 2, because you just found out that when x is 3, y is 4. You just found out that when x is 3, y is also, when x is 3, y is also a 4. So you have 3, 4, and negative 3, 4. Okay, if I do that for the second answer, which was y equals negative 3, now I'd have x squared plus negative 3 equals 13, which is going to give me x squared equals 16. If I square root both sides, I will get plus or minus 4. So what answers do I have out of that one? That's going to give me 4, negative 3, and negative 4, negative 3. So in this particular problem, I have 4 points of intersection where this parabola and this circle intersect. And that is certainly possible. Now, in the case where I screwed that up and I was getting an imaginary answer, in that case we would have thrown out that coordinate, tried the other. You can't get imaginary answers on these problems. All right, now let's make this really fun. You don't have to have just problems that have different exponents. We can do this with all kinds of problems. Exponential functions, logarithmic functions, doesn't matter. But in this case, this one is a mess. I have a log of this x plus 1.1 quantity equals y plus 3. I've got y plus 4 equals log of x squared. Well, that's going to be pretty impossible to deal with. Now, you have a choice here. You can line these up and do elimination. So I would want, in fact, I'm just going to switch the order and say I have y plus 3 equals the log of x plus 1.1. And the second one, I would have y plus 4 equals the log of x squared. Okay. You can do elimination here because you could eliminate the y's. That's one option. I'm actually going to tell you in this case, if you can isolate y all by itself, I'd probably recommend or think it's easier if you simply do a substitution problem. Elimination is possible, and if you like it, you go ahead and do it. But over here, I'm going to opt on a second approach. I'm going to opt to just isolate both of them as y equals. If I had done that, I'd have had y equals the log of x plus 1.1 and a minus 3. Over here, I'd had y equals the logs of x squared and a minus 4. Okay, if I have them both as y equals, essentially it's substitution in place of y, but really if they're just y equals, aren't they equal to each other? So in reality, all I really have to do is just set these equal. If I can get them isolated as both equal to y. Okay, now the question will become, how do I solve this? This is logarithms. Yeah, baby. Well, you never want logs combining with numbers, so we need to get the logs on one side and the numbers on the other. And it's kind of your pick. I kind of think I'd rather move my numbers so they're positive, so I'm actually going to move the 4 over here to the right side and be left with 1, and then I'm going to subtract the logs and make that the minus the log of x plus 1.1. Okay, so then what do you do? Why did I do that? Well, A, number 1, it's going to be easier to deal with the log situation with a 1. B, I know those properties of logarithms. What do you do to logarithms when you have subtraction? And of course the answer is you bet, you divide. So I'm going to change that subtraction into a division problem. So now I have the log of x squared over x plus 1.1. Okay, here we go. I have a problem. There's only a logarithm on one side. What do I do to solve it when there's a log on one side? And recalling, in this case, what's the base on that log? Well, since there's no base at all, yes, this is the base 10. You need to change this puppy to exponential form without doubt. So exponential form, ask yourself, what's the base? The base number is 10. What's the power? 1. So 10 to the first will equal x squared over x plus 1.1. And this is not turning out nearly as bad as it looked like it might. Okay, you're still going, but I got a decimal. It'll be okay. I don't want the fraction, so I'm going to multiply now by x plus 1.1 to both sides. And, of course, it cancels here on the right side. It leaves me just an x squared on the right side, but on the left side, if I multiply 3 by 10, now I have 10x plus 11. Golly gee, I wonder if I can solve that. I'm coming over here. I'm going to set it equal to 0, which will give me x squared minus 10x plus, or excuse me, minus 11. I think that dude will factor. I think a minus 11 and a plus 1 will do the trick. And so I can then know that I have solutions of x equals 11, x equals negative 1. All right. How do I get the resulting y coordinates? That one's your pick. I have to go sub those back into one of the equations to get the y coordinates. I can do that by going back into either of these original functions. They're both y equals. I'm out to find y. So it's a matter of, do you want to stick it in the plus 1.1 or do you want to stick it in the x squared? Well, I don't think I really want to deal with decimals all that bad. So I think I'm voting for, let's go with the y equals the log of x squared minus 4. So if I now go subbing into that, if I sub in x equals 11, I will have the log of 121 minus 4. Well, I thought perhaps maybe that would come down to something decent. But that's a base 10 log. 121 is 11 squared. So there's really nothing I can do with that unless I choose to turn it to a decimal, which I don't believe the book did. So you're not going to like this. But what they're going to do with it is they're going to write that answer as x is 11 and the y coordinate is the log of 121 minus 4. That's a really horrible coordinate, but it is what it is. If I go sub the negative 1 in, hopefully I'll get something better. If I sub negative 1 into this orange equation right here, negative 1 squared will be 1, so I have the log of 1 minus 4. Okay, you have to think about that one a minute. What's the log of 1? That's a base 10 that you can't read there. But if that's a base 10, 10 to what power equals 1? Well, yeah, 10 to the 0 power. Anytime you have the log of 1, it's 0 because anything to the 0 power is 1. So that's 0 minus 4 or an answer of negative 4. So my other intersection coordinate would be the lovely negative 1, negative 4. That's a nice one. The first one isn't so nice, but let's face it, you're living with logarithms. You aren't guaranteed nice answers. Okay, so those may prove a little more challenging when you get to some functions that require you to remember your logs. You have a problem that has ease in it, which is the method to solve it is one that you just did on your last test over logs, so you should know how to do it. Our last thing we want to solve is a system of inequalities. Notice I have less thans and greater thans, and I fold up a piece of graph paper. If you'll recall, when you solve inequalities, you have to shade and find where the shaded regions overlap. So in our case, we would be trying to figure out where these two particular regions overlap. Okay, what shapes are they? That's going to help because since that first one is x squared plus y squared, that's clearly not a line. And yep, this one is a circle. Center is going to be at 0, 0. What's the radius going to be? Square root of 25 or 5. So we're going to need to draw a circle with a center at 0, 0 and a radius of 5. So I can go 5 units in all directions. 3, 4, 5. Okay, and in my case, I'm going to cheat. In your case, you're going to have to just do your ballpark best to draw a circle. I'm going to cheat on mine and use the circle tool to draw this thing, if I ever get out of the tools. Let me check here. Is it going to? Nope. Why did I lose it? We'll see now if I can get a circle. I'm starting at the middle and pulling outward, and I'm going to get ballparkishly close. Maybe not perfect, but pretty reasonable. Looks like that's as reasonable as I'm going to get. Now the question is, if I'm going to shade this, am I shading in or out? You either have to be inside the circle or outside the circle. How are you going to know? Well, in this case, it's all about common sense and that lovely less than sign in there. It says it wants the circle to be less than 25 or less than the radius here. So consequently, since it wants it to be less than that radius of 5, we know we need to shade it on the inside. So I'm going to shade the inside of the circle. Oh dear, I should have used a big marker, sorry. Let's go to the big marker. And yes, my shading is not perfect and I'm going outside the lines and I'm going to flunk kindergarten. But close enough. Okay, so we have that region. The second region, what shape will that be? Well, that's a line. I don't care which way you choose to do the line. I'm going to show you both reminders of how you can graph a line. This is purely your pick as to which one you prefer. I can do the good old-fashioned t-table and sub the zeros in. If x equals 0, y is going to equal 5/2 or 2.5. If I put 0 in for y, x is going to equal 5. That's my personal preference. You could, however, also choose to subtract the x, isolate the y, basically get it in slope-intercept form. So if I divide it by 2, I'd have y is less than or equal to negative 1/2 x plus 5/2. And I would have to plot that using slope and y-intercept. I think I'm going for the coordinates. So 5 over 0 up means right here at the edge of the circle on the right. 0 over 2.5 up means I'm up here. And is this another thing I forgot to point out, is this a solid line or a dotted line? Remember, if it's got an equal sign, it's solid. If If it's just a less than sign, it's going to be dotted. So in our case, this one is indeed solid. So I'm going to attempt to draw a solid line through here, through those 2 points. And then I'm going to cheat and extend my line outward. And then last but not least, I need to shade this one. Well, how do you shade a line? Well, there are 2 ways once again. We can do a quick sub in of the point 0, 0 to see which way to shade. So if I subbed 0, 0 into this equation is, oh, it's not letting me right here, I lost it. I can go is 0 plus 0 less than or equal to 5. And yep, that's true. It is. So since it's less than or equal to 5, I should shade towards 0, 0. The other option is I can come down here to where I solve for y, and I have my y coordinate is less than. That means I need y coordinates that are less than the graph or y coordinates that are below the graph. So you can also do it this way and look at it and go, oh, I need to be below the graph. So once again, whichever way works best for your brain, go for it. But I'm going to go ahead and shade below this line. Both methods gave us that particular situation. So if I'm shading below the line, I am technically shading everything out here. But in reality, what am I looking for? I'm looking for where the regions overlap, and where do these regions intersect? Well, it's where the yellow and the blue made green. And so, yes, my actual solutions to this inequality would be the points here in green that are inside the circle but below the line. That's going to lead us next class to linear programming, which is a major concept in the real world, and we're going to spend a couple days on. So hopefully you'll enjoy the graphing and shading. You get to color. The first part may prove a bit of a challenge. So enjoy and stay on top of it.